and welcome to Cherry Pie Math. This video is going to go over one-step equations, which is a step before two-step equations, believe it or not. So before this video, you should know the inverses of basic operations, so like addition and subtraction are inverses of each other, and then multiplication and division are inverses of each other. You need to know what a variable is and how we use it, and then you also need to know PEMDAS, or the order of operations. So just a thought problem to get started, let's say Marilee has a company that sells t-shirts. Each t-shirt costs $6 to make. If Tomas has a budget of $48, how many t-shirts can he buy for Marilee? So just take a minute and pause the video and think about how many t-shirts he could buy. Okay, and with that, let's take a look at this equation that I made here. What does the equation 6x equals 48 have to do with the question from before? So we know that each t-shirt costs $6. So if let me actually do this in a pen. So here's my t-shirts, woohoo. So this is $6. So let's just keep going. $6. $6. So this is 12, this is 18. I just keep going. That's another $6, which brings it up to 24 total. And then I have another t-shirt, which brings it up to 30 total. Then I have another t-shirt, which brings it up to 36 total. And another t-shirt, which brings it up to 42 total. And then finally, this last t-shirt, which brings it up to 48 total. So that means we had 1, 2, 3, 4, 5, 6, 7, 8 t-shirts. But if we look at this equation, 6x equals 48, I'm going to do that up here. If we say that the x represents the number of t-shirts, we would say that 6 times the number of t-shirts is equal to 48, because that's the amount that we're looking to spend. And that's a lot easier to handle than drawing, 8 t-shirts in order to find my answer. So we're going to be dealing with equations like this today, where instead of drawing every single time we need an x, we're going to find a shortcut using inverses of operations. Okay, so to solve for x, or any variable really, it just means to find, I need a pen for this, find the value of x that makes the equation true. And we can kind of see that in the last one over here, where I said, okay, well, we have 6x equals 48. We were looking for the number of t-shirts. The number of t-shirts was 8, and that's the amount of t-shirts that made the equation true. So it's finding the value of x or a or b or whatever the letter is, whatever the variable is that will make your equation true. And it has a lot to do with PEMDAS. So remember, PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. We use PEMDAS this way to simplify. And we will often see that when we substitute in numbers for x. So like you multiply the number by x first and then you add or subtract or whatever. But when we're solving, we actually want to go back, because we want to go back to what we substituted in, I guess. So we are going to do SADMEP for solving. So whenever we solve, we actually go in the opposite order. We're basically taking away the layers of things that have been applied to x in order to take out the value of x itself. So let's keep looking. So think of it as socks and shoes. When you put on your socks and shoes, you do socks first, and then you put on your shoes, unless you're just a super weirdo, in which case there's no hope for you. I'm sorry. To take it off, you would take off your shoes first, and then you would take off your socks. And so you're basically undoing what you applied in the first place. So let's take a look at this in terms of like socks and shoes. So if I was to substitute x equals 4 and simplify, first I would multiply it by 3, because, I'm plugging in the 4 right here. So let me write that up here. So I would have this, and then I would multiply it by 3 first, because according to PEMDAS, you do multiplication first, and then you would subtract 5. When you're solving for x instead, what you would do, and you would apply it to this other side, applied to other side. So in this case, the other side is a 7. So I would switch it. I would first, instead, I look at the last thing on my other list. I'd say, okay, instead of subtracting 5, I'm going to add 5, because that's going to undo the PEMDAS. And then I would look at the first step. The inverse of that would be to divide by 3. So let's see how that works. So in this one on the left, I multiplied by 3, so I had 3 times 4. And then I minus 5, which became 12 minus 5, which became, so that's step 1. And then step 2 was to subtract, and we got 7. Over here, since we're inversing it, you would take the 7, which is on the other side, and you would add 5, which is 12. And then you would divide it by 3. So 12 divided by 3 is 4. And you end up with exactly the same value of x. So solving is really just looking on this side, thinking about what is the PEMDAS on this side, and then doing the SADMAP on the other side in reverse. So when we're solving for x, we need to keep the equivalence of the equation. We can't just apply numbers willy-nilly. I can't just, like, if on one side I'm subtracting 5, I can't add 7 on the other side, right? I have to keep it the same. But our goal is to get x by itself. So everything we're doing is to get x by itself when we're solving. And we do this by applying the inverse of each operation in the equation. So instead of adding, I would subtract. So let's solve for x using 2 different methods. So the socks and shoes methods we've already kind of gone over. So I would say, okay, first on this side, on the left side, or the side with x, I'm really just, there's only one thing, I'm just multiplying by 9. So then on the right side, the side without x, I would just divide by 9. And that would look like doing 117 divided by 9, which will come out to be, let's see, 13, I believe. Yep. So then my final answer, and I always write it like this, I always write x equals 13. Always, or x equals the number. You always have to write x equals, or the letter equals. So that's the socks and shoes method. I really like the socks and shoes method because it shows very much step by step exactly what you're doing. It does get a little impractical, especially in later mathematics when you have lots and lots of numbers, but it's a good starting point. The equilibrium method is more what you'll see. It's more what's universally used, and this is the method that I usually use. So I would just write 9x equals 117, and I recognize right away that this is multiplying by 9, because if you think back to equations, whenever you have a coefficient in a letter, there's always like a little multiplication in there. So then I would divide both sides by 9, and I apply it to both sides, because otherwise I'm screwing with the equilibrium. We don't want that. So what that does is it gets rid of the 9, because 9 divided by 9 is 1, that they canceled each other out. But since I did it on the left side, I need to do it on the right side too. And 117 divided by 9 is 13, and there's my answer, is x equals 13. The reason that one works is if you think of it as like a scale, let's say we have 9x and 117 on the other side, because we start out with this equation. We know that those things are equal to each other. If I added 3 on this side and I added 5 on this side, all of a sudden it's no longer balanced. It would be like that, right? So whatever I do to one side, I have to do to the other side. And so to get rid of the 9, I would divide by 9, right? Which means I have to divide by 9 over here. and then that makes it x and 13. But because I applied the same amount of operation on both sides, I didn't change the equilibrium, and I end up with the same thing. So that's the equilibrium method. We usually don't write this part. It's just kind of a nice illustration, but this is what you would normally see on most math assignments. So let's do one more example, because when you have a negative coefficient, you would divide by the negative as well. Remember that negative divided by a negative becomes a positive. And whenever we're solving for x, it has to just be x by itself. If there's a negative in front of that x, it's not solved yet. It has to be a positive x on one side, and then whatever is the answer on the other side. The answer can be negative, positive, a fraction, an integer, whatever, but one side has to be x by itself. So I'm going to use the equilibrium method here. So I see I have negative x equal 7x equals 14. That means that I'm actually doing negative 7x, or negative 7 times x, sorry, on that side. So I'm going to divide by both sides by negative 7. And what that will do is it will cancel out the negative 7. So now I have just x on this side. But 14 divided by negative 7 will be negative 2. Because even though I started with a positive, when we divide by a negative, it becomes a negative. So my answer would be x equals negative 2. And this is why I like the equilibrium method so much better, is because I didn't have to write very much. And once you keep practicing, you can even do this in your head. So, but that doesn't mean that you need to have a preference right now. You can get used to both of them. Maybe you like the shoes and socks better because you like to see each step written out. I've seen it both ways with students. You can use the socks and shoes method all the way through school. Like when I taught 11th graders, that a lot of them would use that method. But that's totally up to you. So think about which method you prefer and why. So some things to remember: your answer should look like x equals to a number. Otherwise, it's not really an answer. It's just a number floating around. Either method is fine, but equilibrium is more used because it's easier for more complex things, and just because like a lot of people use it. It doesn't mean it's better. It's just, what am I trying to say? It's something that people have used throughout history, and so it's just, you'll see it more commonly used. And then PEMDAS is for simplifying, and SADMAP is for solving, so you always would go in reverse. And we'll see more of this in my next video. I'm going to be talking about two-step equations, and we'll see more of SADMAP making an appearance.